In this lesson, we're going to learn about equations of parallel and perpendicular lines. Okay, now parallel lines look like this, right? They are lines in the same plane, so you'll talk more in geometry about planes, right? But for right now, they're lines in the same plane that never intersect. Okay, this is the word we use in geometry for they never cross, right? They never touch each other. These lines just continue on forever and they never touch. Okay, now if I were to put these lines on a graph, what we'd see is they have the same slope, right? Like if this goes up 2/3, right? Or whatever it does, that other line's doing the same. It's also going up 2/3, up 2/3, right? So these lines have the same slope. This is a really important feature of parallel lines. They have the same slope, but they have different y-intercepts, right? Like this line is slanting the same as this one, but it just touches the y-intercept at a different spot. If they had the same slope and the same y-intercept, they would just be the same lines. They wouldn't be parallel. They would just be two of the same line. Okay, so some real-life examples, a ladder, right? The two sides of a ladder are parallel lines. An equal sign or parallel lines, train tracks. Okay, so we do see parallel lines in real life, and in geometry you'll see word problems related to some of those things. Okay, now perpendicular lines are lines that intersect at a 90-degree angle, okay, also called a right angle. Okay, and those are definitely two things you should know are the same, 90-degree angle and right angle. So those are lines that look, let me just do this. So in that case, if I have a line like this, a perpendicular line would look like this, and we indicate they're perpendicular by drawing that little square in the corner. That means a right angle, and so now I know that these lines are perpendicular because that little square is drawn. Okay, now their slopes, right? Parallel lines have the same slope. Perpendicular lines, when you multiply their slopes together, the result is -1. Okay, and that relationship is called negative reciprocal. So this is an example of a negative reciprocal. 2 and -1/2 are negative reciprocals. And notice if I multiply 2 times -1/2, I get -1. Okay, so that's what's true for negative reciprocals always. Okay, when they multiply together, they become -1. Okay, so let's just talk really quick about negative reciprocal because that may be a new term for you. There's two pieces. There's the negative piece and there's the reciprocal piece. Okay, another word that's used in place of negative is opposite. Okay, in fact, maybe that one's even more commonly used, so it's called opposite reciprocal or negative reciprocal. But basically that means you're going to do two things. If I want the negative reciprocal of -4, I'm going to do two things. I'm going to find its opposite, right, or negative. So I'm going to change the sign, and I'm going to find the reciprocal, right? So the opposite of -4, the opposite of -4, the negative of -4, is +4, right? Now, if I want this to then find the reciprocal, what's the reciprocal of 4? Well, reciprocal means to flip over a fraction, right? So 4 is 4/1, so the reciprocal is 1/4. Okay, so notice the result is that I've taken this number, I have a number of the opposite sign, and it's flipped over, right? This was -4/1, and this is +1/4. Okay, how about the negative reciprocal of the number 1? Well, this is +1/1. Okay, so we're going to flip it over. Well, that doesn't change anything, right? Flipping 1/1, just still 1/1. So flipping it in this case doesn't change anything, but the opposite reciprocal or negative reciprocal of 1 is -1. Okay. How about 0? This is a problem. 0 is an interesting one. But just like any whole number, this is 0/1. Okay, now if I change the sign, -0 and +0, those are the same, so don't worry about the sign here. But if I flip over this fraction, I get 1/0. Now remember, 0 is not allowed to be on the bottom of a fraction, so this is actually undefined. So the opposite reciprocal of 0 is undefined, which we can maybe remember, right, when we think about slopes. If this line has a slope of 0, that's a horizontal line, and this perpendicular line has a slope of undefined. So it makes sense that 0 and undefined are opposite reciprocals, because if I make a line with a slope of 0 and a line with a slope of undefined, then they are perpendicular. And last example. What is the opposite reciprocal of 1/2? Okay, so reciprocal right? Or let's do the reciprocal first in this case. And notice I can do the reciprocal first or the opposite first, but I just have to make sure that I do both those things so that I end up with the opposite reciprocal. So the reciprocal of 1 over 2 is 2 over 1, which is just 2, right? And then the opposite of that is negative 2. Okay, so the opposite reciprocal of 1/2 is negative 2. Okay? You're going to stop there and go ahead and find the opposite reciprocal of those numbers.